Okay, it looks like we're live, so welcome back. Today I'm going to be continuing to work on Kano script. Alright, so from yesterday I got the problem solved with the arena. So I can go ahead and go right here. Just gonna quit out of that. Okay, let's see. So basically, the issue wasn't in the arena itself, right? It was with the macro, right? Which I was suspecting. Basically, I forgot to multiply by size of the size of the element, right? So that's what the entire issue was. Quite funny, really. But yeah, that fixed it, so now it works. So I can definitely show that. Bam. Alright, yeah. So that is very much cool. So I guess what I would like to do is probably clean it up still, because right now, if I run it without grind, right? Run that, we leak, right? So I freed it, we free the arenas now, but we still have a bit of problem with the memory, right? So I just need to sort of work on that. So, first of all, here's the tutorial, I'll go over that. In here, we don't have any arena, so we don't free it at all. Let's see. So basically we need to manually free it. Anything that is stored in either of these structs, basically, is what we need to do. And that's not gonna be too hard. And then also, the strings, they're stored in the token arena at the moment. So I have to free it after. I'd like to free it up here before this. So I'm gonna have to move the strings into their own arena, probably. Or some other way of handling them, right? Yeah, so let's go to here. And let's see. So let's see. Anywhere that we allocate anything, we need to fix it. We need to free it, right? So what actually gets allocated? Actually I can look at this, right? So program. So let's see. All of these are dynamic arrays, so they get allocated. So we need to free those. And then let's see. What was the actually that is here. Yeah, so then these have quite a few things that need to be freed as well. I will just yank those, and then I can free them in here. Right. Obviously, it doesn't really matter to free things at the end of the program, but I'm going to be doing that anyway. And there's some during runtime things that we could free as well. So we will get to that. But basically, we just need to free all of them. So how do I want to do that? Right. Bars.data I. And then just at the end, free bars.data. So I could probably make a function for this, right? To free DA, right? Free dynamic array. Well, actually, that maybe should be better as a macro because wait, no, I don't need to do that. Hang on. Yeah, I can just free that because it's an array, right? Right. Makes sense. So yeah, I just need to free all of these. Free functions. Scopes that. That I believe is a dynamic array as well. Obviously, we'll get an error if it does not work. So we can figure that out. Let's see. Free. Quite a few of these. And actually, some of them might be stored in the program, now that I'm thinking about it. Let's see, like the functions and the variables might be, and the structures as well. So we might get an issue if we do this, right? Double free. Let's see. Actually, was that the last one? No. So then we have the program, so we'll get to that. Well, let's see what we get from this. Yeah. Vars unaffected. Yeah. So I need to use actually state vars. Oops. There we go. Okay, and stupid. Okay, so that compiled, but I think again it's gonna So invalid pointer. So that is, let's see. It's kind of hard to tell where it comes from. So let me see. Background might tell us. Invalid free. And let's see. So Main 41. Yeah, so that's what I thought. So the structs. So those are already free, so we're good with that. All's good. And then it works. Okay, yeah, so the rest of these need to be created separately. So that works out. And then we have the program. So what is in the program? Yeah. Program. So that has these. So we need to create these as well. Which actually, some of them might be the same thing. But let's see. So let's free data, and actually fix this right. So it's program. And then we have functions, structs. So I'm pretty sure the functions, structs, and var. Actually, they might all be the same, because the nodes are stored in the node. In the node, trying to think, right? The node arena. That's what it is. Yeah. So we have the same issue. So let's see. We can run Valgrind and make sure, because I want to make sure that it's all free. So in let's see, what is it? 45. Right, so it's this one. Oh, that's wait, what the heck? Oh, I forgot to change it. Shoot. Hang on, what is it? Structs and volumes. Okay, there we go. Let's try that. Yeah, so still obviously there, you know. And let's see. So 45. Right, so it isn't like that. It's gonna step through them one at a time. Here as well, 44. So the one right before it. Yeah, so I'm pretty sure all those. Actually, they might all be. Yeah, like every single one, actually. So that is. So 43, yeah. And then this last one as well. It is the same. Yeah, alright, perfect. So we didn't even need to do anything with that because it is just pointing at things that are allocated elsewhere. And there we go, so now it runs. And let me actually run the Valgrind again. And let's see where else we might be leaking. Alright, so there's just a little bit more. We can, let's see, can we? Loop check equals full. And let's do log file. What's log? We can take a look at the log file, yeah? So, let's see, custom reality. Ooh, okay, yeah. So that is, it's all in there. So I knew that this would be the case. So that's with the things that we have to allocate, right here. Right here, for the file name, we allocate some things here. So let's see about that. Where we allocate it, and then we return it, that would put file name. So we just need to basically free the file name. That should be mostly it, right? Was there any other ones? Gen program, 514. Block stack. Why is that? Okay, it doesn't like that. Alright, let me do the file name first. So we can fit that at the end as well. Oops. And let's see, where is that at? So we passed this file name. Do we change it? Let me go in here and see where we call it from. Char output. Yeah, so we can just actually figure it right here. And we're golden. Should be it. Okay, get rid of that. Add it here, make that. Run it. Still runs. Run this, and let's look at the log file. Okay, so we still have some lossage in there, so that's interesting. Let's see. So, ooh. Yeah, so we allocate twice. I did not see that. So we allocate that. Start line of output. Can we free the output? Let me think about after this. Yeah, because we do that, so we can free it right there. And that should be good, right? Alright, still runs. And if we do this, log actually. There we go. So now we just have this issue in here, which is quite interesting. So what's the deal with that? Custom reality, gen program 515. Right, why is that? Ooh, okay, because we're appending it. Wait, no, but block stack. Do we not free that? We do not. So free state dot block stack dot data. I just forget to do that because I remember doing it. Okay, so now we should be actually good. Yeah. So it leak. Oh, okay. So we still are missing some stuff. Hmm. Show leak kinds all. Let's do that. Show leak kinds all. It's like these leaks aren't really big deals. But still, I would like to take a look at it. So let's see. Ooh, in generate 698. This is the wrong file. So we open the file. In fopen, fopen. Interesting. What is that about? Oh, because I don't have to close the file, obviously. Yeah. Okay, we should do that before we free it, probably. No, I guess it doesn't matter. It's just a file name, but regardless. Then it runs. Alright, yeah. And then run this. And look at the log. And we are good. So all heap blocks are freed. So there we go. Yeah. So it's not like ideal necessarily. Because we're still using a lot at the runtime of the program, right? Because we free it mostly at the end. So I think what I like to do is probably just have a separate arena for strings. Is that going to be the best idea? I could just copy the strings, but I don't know that I want to do that necessarily, because then there's stuff to keep track of, and I'd rather just not really think about it, right? So, let's see. So, arena. Alright, so we can put it here, right? So this will be arena, string arena equals arena init side of character. Okay. Let's see. So what times, arena initial size? So we're probably gonna have a lot of strings in here. Yeah, so we're gonna basically pass this to every single one of them because they're all, well, no, we're gonna pass it to this because this is when we go and allocate it, I suppose. So let's just pass the string arena, and then yeah, we can go into here, arena string arena, and I had to update every instance of it, right? So the header file as well. All right, arena string arena. And on this parameter, that is all good, all good. Okay, so let's see. So we do have generate string. So this arena that we want to use in here, we want to pass that. So if we go to generate string, we want to pass the string arena. Generate string arena. And all right, so that was the only call to it. So was that good? Is it now? All right, so we don't get that. And then if we free it at the end, right? Arena free string arena, right? Let's see. Does that? So it should not leak, right? So it runs. And then if we let's see, I'm gonna leave that there, but this one I want to try to free after we parse, right? Like that. Variable reference. All right, so somewhere else we are allocating that. So something to do with variables. Yeah, append. So we could go to all those, right? So this is we're appending to the arena. Yeah, okay, generate string. Yeah, no, but that's fine because this is the right arena. Here, yeah, this is the token arena, so that is all good. Equals view create. So where are we allocating this? This gets allocated generate string, so we're good there because we're passing the string arena, right? Let's see this as well. Setting the value.string to that is alpha. We append to the arena the word. Okay, I see. So, what is this? Okay, yeah. So this needs to be a string arena. And then at the end, let's see, do we use that anywhere else? Yeah, so that should be good then. Let's see that. And run it. Okay, so it does run. And what does Valorant look like? And let's see. Okay, so alright, so we still have some of those. No. All three blocks are free. I misread it. Okay. Yeah, so that works out. That many bytes were allocated. That's not even that many. Yeah, so now we can free the tokens earlier, so that is nicer. Let's see, so I kind of get rid of that then. Alright, that is good enough for a commit, I believe. Alright, let's see. Free all heap blocks. And open arena. Okay, there's that. And let's see. So, let's see. Okay, so what is that? Probably put some stuff here. So this is the freeing the token arena, right? So that is good. Block stat. I kind of want everything to be very clearly. So this is allocated. This is after because it is because it's what because it's not used in the read file view. So we allocate it when we need it, right? And generate. All right, and then we free the arenas. So all these frees can go together, right? And probably can make even a function for this, so I don't have to have all this extra stuff here. Okay, so that looks pretty good. Alright, and it runs, and let's see. Timer. Is it slower now? This seems to be a bit slower. Right, maybe not. What's that song? That's even faster, what? How is that faster than the simpler one? Oh, wait, what the heck? Okay. How long is this thing, right? Let's do this one. Wait, what? Oh, that's the long one. Alright, so that's the longest. So printing that out would be nice. Alright, and let's try to emulate it as well. Tired. Yes, that actually takes quite a while now. Obviously, this is an affected by the arenas. Yes, that is. Was it that slow before? I guess it was. It was 20. Because the C one was 10, right? Is that right? I still have it here, so I can time it, right? Oh, no, the C one is very fast. Oh, yeah, but I don't have optimizations turned on or anything. Yeah, so we're good. Alright, that's not too bad. Yeah. And this, we don't have any optimizations currently, for the generated code. So it is gonna be slow. Wait, so that's actually pretty good. That's most of what I wanted to do already done. So let's see. Yeah, so probably the next stream will be moving it all to actually generate the bytecode rather than generating the assembly like this. And it's not gonna be that difficult because basically I have this function, right? So right. What program file right here? Okay. Basically, I pass a machine here, and it writes it to the file, right? The machine is this. Machine. Where is it? Machine. It's down here. Yeah, so it has a few things. So, the registers, that doesn't matter. Because that's not part of it. We don't even really use that, so I can get rid of these. We have basically the important things. The instructions. The, let's see. Some of these are runtime things. And we have the, string stack. Where is that? Oh yeah, string stack right here, which is a stack of strings. It's basically all the string literals, right? And that is pretty much it. And the entry point, right? I don't even know if I set has entry point, but anyway, that's what we have. So basically, what we have to do is whenever we encounter an instruction, such as wall, right? Then we need to wait. No, what is this? Oh yeah, this is a label. Okay, that's a label. Let's go. Yeah, call. Let's say call, right? So that has an operator. So that's a good example. So we have an instruction here. So we need a few things here. So register index. What is that about? We do not need to set that. We have the data type, which is is that needed? I don't know, but we have the instruction set and the value. Oh yeah, we do need the data type to know what the operand value is. So this is the operand, so I don't know why I call it value, but basically we have the instruction set type. So this would be type call, right? And then we have the word value, the value. In this case, it would be wherever we're calling, right? Which is going to be an absolute position. Yeah, so we need to basically keep track of labels. That's the only part that's going to be somewhat complicated, right? The rest of it, like, we can just go through, get all the strings, push them to the string stack, and then we just have to save the index to it. So when we get the string, it just is an index in the string stack, right? And then it allocates it to the memory and all that stuff. So it's really not going to be too difficult to change. Again, the most complicated part is going to be the labels, because basically they're not actually going to exist. It'll be a nope instruction, right? Which maybe even could get rid of that, because that does waste some time. So, but basically the point is, the labels are not gonna, they don't actually exist, right? But yeah, that's pretty much all that I have to do. And it's not going to be too difficult. So I can just maybe even make this into a header only file, and then just, include it. And there we go, just start calling it and stuff. That could be cool. And then it'd be very modular, So. Yeah, so now, no more memory leaks, that is poggers. No valid client errors. Let's see, actually, let's try, like, the suppressed ones, right? So we had that. Times I like this. Oh, yeah, let's do, I think, -s, right? Okay, yeah, so there's nothing here, so that is very cool. 0 errors from 0 contexts. So, pretty poggers, pretty poggers. So. Let's see, yeah, so that was the plan. I thought that would take a bit longer to set up, but alas. Let me think. Yeah, so, like, would it be beneficial to, instead of using Arena, use something like a stack allocator, where you can push and pop from it, right? Would that be beneficial? I don't know. Right, because, really, we need to allocate all of the tokens, and then we just want to free them out all at once. There's not really a time where we want to pop from it. Same with the strings, because we need to use them all throughout the program. And the nodes as well. Yeah, like, we could kind of free them, like, after we, loop through the nodes, but even then, I think it's better off just as an arena. I think that makes the most sense. So, let's see. Right. So let me take a look here. So I want to test some things out to make sure that things still work. Yeah, so we'll do this again. And let's actually, let's pass X there. Oops, so we'll allocate just a thing here. So this will be let's see. Call main Z. And yeah, this will actually return X. Return it. And then let's see, so this will be Z. Two. And I forgot to change this. Okay, and let's see. 27. Don't think that's right. Make Z. Pass Z. Was X plus 1? Why does that not work? What? Okay, that's not good. That is a problem. Is it because of this whole thing? No. Okay, so it just doesn't work. It's interesting we can call that as well from there. Why does that not work? Return X, we're returning an integer from it. Setting it to foo. What if I return X plus 1? Still doesn't work. Okay, that is a problem indeed. And if I do that, next outer range. Okay, why is there so many problems? What the heck? I swear it was working before. Okay, what is outer range? Let's see. Yeah, this is pretty simple, right? So we push 14, so that is the value, and then we're calling main. Main is here. Push 0, and we indupe. Oh yes, that's the index that we indupe. I forgot that I changed it. So we're basically grabbing the 14, right? Grabbing 14 from there, and then we push 1 and we add to it. and push 1, so that's where we're swapping it to. So let me keep track of the stack actually. So we have 14 here. Then we push 0, we undo, so we get 14 again. Push 1, add this becomes 15. Push 1, and then index swap that, so we get 14. So why are we grabbing that one? That is not right. No, we're not. Wait, hang on, we're in swapping. Oh shoot, no, we're in swapping with this one, so it becomes like this, 15 and 14. So that is right, and then we pop this one off. Wait, what? And return. Down here, get the stack size. So in this case, it's 1, push 0, subtract 0 from it, so 1. Why are we subtracting? Oh shoot, wait, hang on, what? Push 0 sub, and we index to this one. So 0, 1 in that case. Yeah, so something is not right. Alright, let me go through that again. Alright, push 0, which is what we're into, so we get 14 again. Push 1, add, it becomes 15. We push 1, and then we in swap with that, so we get 15 and 14. Well, actually, no, shoot. This needs to be 2, right? Is that right? Hang on. Hang on. I don't remember how in swap works. So if we in swap 0, that just swaps with the top one. In this case, yeah, so it would have swapped. So we would have had 15 and 14. Then we pop 14 off, and we return here. Stack size is 1, push 0. So this needs to be push 1. Is that what it is? Indupe, because we can't indupe 1. That's what the issue is. Right, so if this was... why does it think the stack is greater than it is? Oh, shoot, is it? I know not. Because we don't have anything allocated here. Like if we set foo to 14. Foo equals main 14. Then it does work, okay. Yeah, so that is, I don't do these. Do this. Where we allocate X right next to it. Where, oh shoot, this needs to be like that. There we go. 14. Yeah, that's not right either. So it's like one off, when we call a function like this. Because it needs to not, I think what it is the stack that we're keeping track of. The index is wrong, right? Dang. Dang. So what if we have local variables, right? So what if we call this in the main? So this can be iter, say. We have a main function, which is void, right? Oops. And we say that, and we call iter 15. Iterate 15. Yeah, so we do that, and then we exit with x. So that should be 16, right? Yeah. So I did everything right. 0. Yeah, that's not right. But if I allocate a variable, I call it in there, then it's going to exit with this variable. Exit 0 still. Interesting. Okay, it's just only exit with 0 now. What the heck? Some big issues for sure. Shoot. Okay. Let's go back to this now. That's 15, and that is not right. So it's exiting with the wrong variable. So let's look at this. It's easy to read like this. Stack size, push 1, sub. Yeah, so this grabs, it depends on the size. So we have 15, and we have the stack size, which is currently 1. Push 1, subtract, so we grab 0, and we indupe 0, so we get 15, right? That is correct. We call iter, then iter grabs the stack size, which is 2, pushes 1, subtracts, so it becomes 1. We indupe 1, so that is this one, 15. So it's grabbing this one right here. Why are you doing that? Oh, because we're iterating. Okay, indupe, and then push 1, add, it becomes 16, that is correct. And push 1, and index swap with 1. So in this case, right, it's 0 and then 1. So 16 and 15. Off this one. Alright, then that case is right. Okay, so this is right. So it the functions are working properly. Then return here, and we grab the. Let me move this down. That's not right. This down here so I can calculate better. 15 and 16, right? Grab the stack size, which is 2, push the sub 1, and we end up 1. So yeah, that is wrong. So it's wrong there. But if this is not allocated, or if this is not called like that, wait, no, I was Xing with the wrong one. Hang on. Yeah, okay, so it doesn't work. But if this is set to a literal like that, then it works, right? Yeah, okay, so it's an issue with the stack size when we call a function. So we need to we have to not do. We need to not iterate it because it gets iterated by the call. Is that what it is? Iterating one too many. I don't know. It's hard to tell necessarily. So, push one. So that's like the stack location of it that we know, which is correct. Which is correct. Let's see. The stack size is on. Because so the function returns a value. And then right, if this was 0, so really we want to grab the top of the stack. That's what we're trying to do here. So push 0 sub. Right, so this should work. Next iterate. Okay, what? Why is that? Wait, what? Oh, shoot. Wait. I need to set this. I forgot to update this. So iter L. X, run that. Yeah, so that is what I need to edit. So that needs to be 0, right? Still iterate. Okay. Yeah, because you can't just use the stack size. Exactly. So that doesn't work. So what is this value that we're getting here? So let's do global indupe. So we get the stack size and we push the value. So what's the value that we're pushing, right? Index, which is alright, yeah, so it's the variable locations. That's what I thought. So this is the first variable, right? That's what we're trying to grab. We want to try to grab the second variable. Then it works. Okay. Yeah, so it's trying to grab the first one. For some reason, it thinks the index is 1. I'm not iterating it properly when we are calling. Alright, let's see. So the location is incorrect. Let me look at GV, right? Let me break in the gen program. Let's break there, and then I'll run with okay. I want to look at when the variable is being allocated, right? See what it is. So this is the function. So you can just jump through that whole function. Then there's return. Okay. And now we are at the end. Okay, yeah, we got to go through all this function stuff. And now we should be on variable allocation exit. What is that? What's that for? Yeah, okay, what is? Oh shoot, because we generate the variable separate. I forgot. Okay, well, we will continue to there and run it. Alright, there we go. So this is where I wanted to look. I still got messed up for some reason. Alright, gen var deck. Let me jump into that, right? I just want to see how it gets the it's the stack. So state.stack size is 1 at this moment. Okay, and that is the first variable, so that is correct. Then we go to the next one. Step into it again. Go through all these. Same thing, and print state stack size. And it's still 1. Okay, so that's the issue. We need to iterate that. So let's with the function called gen yeah, right here. So the stack position doesn't get iterated when it's a function call. So that's when it's an array. Really just we're iterating this. We're calling this expression, right? And let me look at this quick back. Yes. So what is the issue? Like, why does that not increase the stack from this? You know what I'm saying? So it's in Gen Expert where we have the issue there. So Gen Expert. Okay. Right here. Okay. So what I'm looking for basically is a func call. Yes. Functions. We get the function, and we generate the function call, and we decrement it by one. Why make that? Generate this expert, and then we do the function call. Okay. So is this something? Let me do that and look at the function call perhaps. Enable and break on. I'll do the gen bar again. Gen bar. That actually is what it's called. Run. Okay. Yes. Yes, you. I'll go to the second one, and I will go through here. Go to the gen active. Step into there. And it's a func call, so that is correct. And let's put the function. Okay. Print function dot value. Print function dot name. What is it? Function name is. That's the name. Oh yeah, because it's a string view. So print function dot. Yes, the len is this because it's just a view into the entire thing. So this is what we're looking at here. Why is there repetition? Oh yeah, because that's what we're calling. All right, so this is the name basically right here, the iter. So that is correct. And actually, probably even do view print. Is that a thing? Hard function that thing. Can you call that from it? No, that doesn't work. Okay. So we're doing that. Print expert of value call count is 1. Switch in the expert. Print state stack size is 2 at the moment. So that is what we have at the moment. Gen func call, we'll jump into there, and we're just calling that. Okay. The thing is, we're popping it off, even though it's not a void function. Is that what it is? Is that what the issue is here? And we need to check if it is a void function or not. Because then, yeah, we decrement stack size. So that's that could be problematic. So let's do if. Right, but what if we have a lot of extra stuff here? You know what I'm saying? No, because that's fine. If state, not state, but function dot type, maybe it's data type, equals void. Is that what it's called? I believe so. It's something like that, right? Really, it shouldn't be though. Dot. Alright, back to files and then run it. And that is correct. Okay. I do need to test it to make sure it did not break anything else though. We can use this rule again. That is not working. Okay, so ran into an issue. I'm gonna be right back though. Not too much. No. What is it? It's quick break. Alright, yeah, about 3 minutes. I'll be right back. Okay, and we're back. So let's take a look here. Tech faults. So that's tech faults now. That is quite a bit problematic. It's tech faulting at the runtime though. That is interesting. Hard to tell where that's gonna be at though. So what if what is this? So yeah, so let's see. Where do we no. Oh, yeah. Let's see. So where are we calling this and setting the value equal to the return event? You know. Right. Let's see. Let's see. And so that's not anything like that. This is only for function calls. So when we are calling a function call, that should be the only thing that changes it. But we're calling function calls here. And those are all void. String compare is not. So it's probably in the string compare. Ooh, yeah, in here. So this, it doesn't decrement the stack size. Right. But it should be. I don't know. Let's put this back. Right, so if we just decrement it, then it works. But it's not correct. I need to recompile it. Then that still works. So, right, because we want that to keep the value. And that's not a void function. It does return a value. What is the value then? So let me perhaps step through in gb run. Let's break on this. So break on gen expert. We can run this one. That'd be fine. Yes. So we'll continue to the next one, right? And then here we'll print expert.type, which is a func call. So let's go into the func call. Print function.type is type int. Okay. Yes, that's fine. Size. Okay. Right. Let's go to that. Okay, so that it's not. So it's not gonna decrement it. That is correct. So let me think. We make it 1, right? We push onto it. Then it's 2 from this. Let me think. Let's look at this. So we need to do something here. Gen alloc. Why is that messed up? Stack size plus less. Alright, I need to fix all of this. Quite a bit of a problem. Let's see. So if we increment it there, it breaks everything. Fire, and 10. And that is obviously wrong. Okay, yeah, so that is not right. I'm gonna set to that because. Okay. If no value.var.value.data is 0 type not equal type void, then state. I don't know. I need to think about it because I'm not sure. Right, because the expression should have a type. Value.type. No. That is no. Alright, that's not right. Go back into the expert. Unsure. Okay, gen struct value, gen built in, gen expert right here. So get the function from expert value dot func call dot name. Generate the expression. Gen func call. And that's just generating the like call whatever. And then we have to decrement it because that we pushed onto the stack with what? What pushed onto the stack? No, because it doesn't consume anything from the stack. So why do we have to decrement for this arg, right? What if there's more than one arg? I don't know. That doesn't seem right to me. Right, like this has more than one arg. This does not though. Okay, now let me go back here. That's out of range. Then we get the right one, right? Because yeah. So what we need to do is if the value call, we need to basically remove all of it and then push one. Yeah. So let's do folder size t 0 I is less than expert value dot call dot args dot count I plus plus. So we need to do that. We need to pop them all out. Basically, state stack size. You know what we could do is we could just do this in here, right? Because this doesn't matter in this case. Actually, it might. So we want to do it after, because we want the stack to be appropriate. And then we can do state stack size plus plus if expert if function dot value no, function dot type does not equal type void. Then we can increment it by one. And arrow type. Echo that. Alright, that is correct. And what if I get rid of the second argument? And it's still correct. Alright, and let's look at 110. And it works. Okay, thank goodness. Alright, yeah, so the issue, we're pushing based on the arg. Man, that's kind of funny. So it's kind of funny. We're pushing based on the args, right? Because this pushes to the stack, because we're generating the expressions required. And then we were only decrementing by one. But what we want to do is we want to remove, like we want to basically pop these off of the stack, and then wanting to increment it if it's not a void. But the funny thing is, in this rule 110, the string compare, what is the string compare right here? The string compare, it took two arguments, right? So we're pushing two arguments on the stack, then we're popping one off, and it returns a value. So it was essentially the same as the same outcome, but only in this specific scenario where it's returning a value and it has two inputs. And that is why it was broken here, because this was not working, because it only had one input, and it was returning a value as well. So it was basically just, it was pushing the stat value on and then popping it off. So that is quite funny. So there we go. That fixed the major bug, and hopefully that fixed it with this as well. Right. So if I do it in here, oops, it should still work. And that is incorrect. All right. So it does not still work. Okay. That's something I need to look into. Let me push this first. Fix bug with functions. Expert. Where the value was not returned properly. Okay, push that. And it wasn't even very big. Alright. So let's look into this one. So why are we getting 0, right? 0 is push 0 into. Yeah, so I need to sort of walk through it. Let's start here, right? So we jump to label 0, so that's right here. Then we jump to label 1. Alright, so we're just kind of jumping around. Jump all the way to the end. Label 1. And that is nothing. Wait, what? Oh shoot, then it just ends. Because I don't call the function. I don't ever call the bloody function. Yeah, because there's no entry points. Yeah, so I need to call the function. Then it works properly. Okay, so that wasn't an issue. That was just me being kind of stupid, right? Yeah. Like, and I don't want an inch point because it's like a scripting language, right? Any like, some way to set it probably like I don't know. Maybe just even something as simple as export main, right? That's kind of simple and then it's kind of clear. And if you don't set it, then it just executes like a script. But for now, this works, right? Main, let's call it there, and that. Okay. So 16, yeah. And I just want to make sure it's right. Right regardless. So I'm gonna make this see if I pass it out here, it should still work. 13. Alright, yeah, no, it's good. And if I exit with L, should get that probably. 15. Okay, yeah, so everything seems to be working now. That is superb. Super fantastic. Pass value in here. Val. And let's iter val exit with X. So then we can pass anything here. So we'll pass 12, right? And it should exit with 13. It does indeed. Okay, okay. Val plus L. And it should exit with that. Okay, so that should be shoot, so that's gonna be 15 plus 12. And then it's gonna be one more. Okay. Alright, perfect. 28. Okay, okay, okay. Perfect. Perfect, perfect. Okay, that seems to work. X with X plus 8. That should work as well. 43, okay. Yeah, so it seems like everything's working out. That was a bit of an oversight, and I wonder how long that was a thing, you know? But yeah, glad to have fixed that. So basically, out of the features that I have, at least what I'm aware of, right? Let me see, I have some issues here. So, the ones that I'm aware of, I don't remember what I meant by this. Right, so that's not gonna, I don't think this applies anymore, but I'll need to look into it, because I don't remember what I meant. Let's see, cannot return an array from a so you can't do that, but you can return the pointer to it, so I think that's not even that big of a deal. Like, let me test that. Let's say, we have a function, right? Function, iter, right? So I'll just call it, foo, perhaps, instead. Foo, okay. And we have an array that we allocate in here. Y, y, 3 equals 1, 2, 3. And then we can return y, right? And we'll make this return void. So it's going to return the pointer to y. Not return void, return pointer, that's fine. And a pointer, and we can call it in here. So this returns void, so we can call foo, set the second value to x, foo with 15, and we'll set L pointer equals that. And so now, right, this is just a void pointer essentially. I don't have type pointers at the moment. And then we can return that, and we can go ahead and exit it L2, right? And that should be L1 rather, and that should be 15. 15. Okay, let me actually make a function that's like say print array, and this just takes a pointer to an array. Let's call it array. There we go. Returns nothing though. And it just basically outputs it. So we need print in now. Do that. Alright, I don't have that, but it is in here. That's not right. Yeah, remove. Okay, no. And we have this print in. Where is that? Print state. I thought we have a print in. Oh, I guess we don't. Okay, I can grab it from out here instead. Thanks. It's print in into the build. Alright, Kano, print in. And I can grab this function. Returns nothing. And let's go into Kano.Kano. Where is that? Right here. I'll pop it in here. Okay. Print in. So I want to actually call print in. So this is like assuming it's an integer array. This is just for testing purposes. Pointer I. And we need the size as well. So let's do size and wall. S is greater than 0. Then do this. S. And actually want to, want to make a control variable like that. I is less than S. Print that. Okay, and let's try that out. So print array. So that's what we want to print. Print array L, and then I'm just going to I'm just going to hard code it, right? And expected that, but found type. So where is that at? 14. Let's see. Let me see. So 14. Right here. Pointer I. print int. Ooh, okay. Yeah, so that is an issue with the type checking, which is incorrect. Expected that, or that. So that's in the probably in the parse expression. Is that where it's gonna be? Let's see. Oh. Maybe it's not in here. Oh. Let me think. So print int. So it's like the it's like that. Maybe it's in the generation actually. Oh. Oh. Hey, what are we doing today? I'm just going through and cleaning some things up. Typing is the hardest part. Yeah, and I hardly do it at the moment. Yeah. And the place I do it, it's kind of messed up. Anyway, so. Yeah, but there's gonna be like a big thing where I'm gonna go through and actually properly implement it. 30 days still going. Dang. And how complex is your language? Let's see, where am I checking, right? Let's see, is it in here? I don't remember. Expected string or char or ID. Alright, so this is where it's at, it looks like. Yeah, so this is incorrect. Because I identified. I don't have identified. I do have ident. Wait, so what is the type then? Right, it is that. It's fantasy. What do you think of Zig? I've never used it. There is some interesting stuff about it, for sure. And I think it could be beneficial, right? But again, I haven't used it, so I don't know a whole lot about it. It does sound interesting. But I haven't tried. Rust and C, so it's complex. Yeah. Yeah. I think it's really more similar to C++ than C, right? Like it's not object oriented, but in terms of like complexity. So is it we don't have token type array. What did it find? But it found type. Why did it find a type? Oh shoot, because that can't be, that is the wrong name. That's what the issue is. Yeah, there we go. It prints one forever, because I forgot to iterate it. That's nice. It's I plus 1. Not really closer to C. Rust is closer to C. Yeah. Well, it's for sure Rust. Okay. 53. So 1153. Why does it do that? Oh yeah. Okay, so let me print a new line as well. Right. New line, and that should look better. So 1, 15, and 3. And we can also print into the index. Printing I. Right. Let's see, index. We don't really have formatting, so we have to do this. It's that. And there we go. So run that. And index 0, value 1. Alright, very cool. Yeah, I guess the most interesting thing that I've seen of Zig personally is like is the building, like build system stuff. Like I've heard that people use it for C and C++ projects as well. Like use Zig to build it. And that's kind of cool, I think. I like that. But I haven't tried it, but I have heard of that, and that's kind of interesting. So 1, 2. Okay, so that works. We can set the value. Set the value like that. Should be able to change that as well. Okay. Just calls claim. Well, at the moment, right? But they're working on more complex stuff, right? But I mean, like you write the build script in that language instead of using a makefile or something. That's the interesting part to me. Yeah, we can't print negative numbers. Not supported. I was testing it though. Yeah, so negative numbers aren't really supported. Makefile is bar set so low that anything would be. That's fair, but it's pretty popular, right? So, like, it does exist, and pretty much everyone uses it. So, pretty good, but not there yet. Okay, okay. But you write Zig to build it, right? Like the build file is written in Zig. Unless I just completely misunderstand. Correct. Yeah, that's the interesting part to me. Like, if everything that you have to build it comes with the language, then I like that, you know? Like, it installs whatever you need for it, and then you can write it in itself, you know? Like, like Knob, right? It's for C, written by Soding. You probably heard of it. And that is C, and you build C with C, and that is cool as well. Like, you need a C compiler, obviously, but you write the build script in C, rather than having an external tool. And that's like, Zig is built with that in mind. So that specifically is the interesting part, not necessarily any of the things that they've done with the with the with how it's set up itself. Okay, put away. If you go out of bounds, it's not right. Okay, yeah. You can write anything in that build.jig if I'm correct. Same as build rs in Rust. It's compiled to the same program. Yeah, just as the build rate stuff. Yeah. Alright. Change to array size. And we could even have a null terminated array. That could be interesting. And we don't have null like as a literal, but if that I don't have break, so I can't break. If array I, what was that? So I'll just use that as a null termination character. Then let's do all this. Set that at the end. Right, because you can do this right now. Valid size. Oh yeah, because we don't have the of this. Stack overflow. Okay, that kind of stuck in a loop. Interesting. Maybe that won't work. How did you implement name scoping in general? Is global scope and function scope separate, or is it the same structure? Well, it's the same kind of structure, but there is like they're separate ones basically. So, well, no, it's in the same structure. Basically, how it works is we store any variables or functions in a structure, and then just as we're compiling, we just append them to it. And then at that point in time, you can loop over and see whatever there is in there. And all the global variables are just compiled first, and they're set as global. So they're at like the start of it, and they store like their stack size, stack position, and everything like that. But yeah, it's all sort of one thing. Like I don't have a separate scope for each function, or a separate structure for each function. But I'm considering doing that because that might work out better. Because I've had some issues based on how I've done it so far. It's not that though. Mm. Okay. Interesting. Something I'll look at. I'm not sure why it's safe points though. Global scope is a hash map, and function scope is a dynamic array from which values are pushed and popped. Okay. Yeah. So mine works more like the dynamic array. I do want to implement hashing. I just haven't done that because well, it's not built in with C. So I do have a hash map that I can use though. I just had not done that. And right now I haven't written anything big enough where that would even really make a difference. That's the wrong thing. There is some issues with that. Don't worry about that. So some leaks. 739. Okay, so it's trying to do that, and this is the read instruction. Okay. So where is that? All right, there's 2 of them. Try something to do with this. Trying to grab that. Is it in the if statement when you're doing that? Does that not work? Wait, I equals 0. Let's do with indexing it. No, wait, okay. That works. Try that. Okay, there's no 2. Then if there was. There actually had to be 2, actually, I realize. 2, okay. So we can do that. We can't check if it's 0. Oh shoot, no, because I'm not indexing. Yeah, that's what I'm trying to do. AI. 2, so that works. Yeah, because it's printed like before, but we have that. We can't check if it's 0. Then that works, okay. Yeah, I need a way to break, for sure. Then if I add the else here, then it breaks everything. So, that works. Alright, so it's when changing this. Okay, is it trying to index it still? Is it not checking the condition properly? Is it not reassigning I properly? Yeah, that's interesting. So that's something with reassigning the variable in here. So let's see, let's go to the read, because we know it's in the read instruction. If statement. Alright, so this is the if statement, so it's probably not that one. Maybe it is, because it's only 2. if then. So we're reading from it. Are we reading the wrong value? Let's maybe print the values. What if the pointer gets messed up? I don't know. Right. Is it trying to reassign the array here? It's whenever I do something like that, but if I do something else where I just like write or whatever, then it's fine. That is weird. Huh. It's also interesting that it's does that when it's not supposed to. So we shouldn't be reading that value. Oh shoot, because I passed filters, so that's why it does. So it's probably trying to do this still. That's what it is. It does it after the first one. Next for yeah, okay, it only prints that one. Oh shoot. Wait. Is this messed up? Right eye. Equal messed up. Because it's only printing it out when it's equal to 0. And then it must be reading past it. Huh. Okay, I see. So let me look at this. It's in the if statement. Read, compare equal, so that's correct. Reading from it, push 0 if it's equal to 0. Compare equal, bro. Zero, 0. Huh. Compiler, runtime, and language itself. Yes. Very much fun. I will cut out one of those soon, like the assembly part, assembly compiler, but not yet. Equal 0, but it's only printing it. I don't understand. So it's only if it's equal to 0 does it do this stuff. It's nothing. I passed through here. It prints out index 3 values. Why does it do that though? You know. Yeah, then it goes way past. Okay. Yeah, so it doesn't end there. Okay, this is an interesting problem. Fortunately, I do have to go now. Yeah. So I'll probably be looking at it, before the next stream. Hopefully I can get it fixed, right? I'm not sure what it has something to do with reassigning the variable and checking the value of an array. So I'll need to look at that. Yeah, nothing to commit because I was just messing with that. So, yeah, thank you guys for watching, and I'll see you next time.